So as you know, today I will be having this lesson. Burden is not here, as you can see, and he asked me to introduce you to TensorFlow. How many of you have ever used TensorFlow or Keras? Fair amount, not too many, but it's okay. We will be using TensorFlow and maybe Keras during the rest of the semester, right? Up to now, for the homework, we have been using only NumPy because Brendan wanted you to understand what goes on in the algorithms, right? So it is hard, though, to implement certain things by hand, as you saw. Like, we implemented in homework 1 a fairly common loss function, and so with its derivative, which is not that bad. But sometimes, if we have to do like very complex neural networks, if we have to run them, it becomes very bad if we have to code everything by hand, as we did up to now. Plus, as you notice, NumPy is not the fastest way, right? Yes. So yes, today I will just be talking about these deep learning libraries a little bit. So, as we saw from like lesson 1, deep learning is like, it looks very complex because we have a lot of operations to apply to the data that we have from the real world, right? So it looks very complex, and it is. So, as I was saying, it is hard to do certain things by hand. But yes, even though it is very complex, everything can be reduced to just the 4 basic operations, right? So, as a couple of examples, we have the SVM that we coded during homework 1. As you can see, it's just a series of like multiplications and then additions, right? The computer is very fast at doing it, so it shouldn't be a big problem even with like low-level libraries. When we go to MLPs, it's still the same concept, but here we are also applying certain functions to add nonlinearities. And the difference between this and this is that in this case, our W's are actually, what are our W's in this case?
Matrices.
Matrices. Perfect. So, as you can see, this is not like, conceptually, this is not more complex than this, a lot more complex than this. It's just that it gets bigger and bigger, right? We have neural networks that have like thousands and thousands of neurons, thousands and thousands of multiplication, therefore, to be computed, and additions. So if our program is slow, it doesn't depend on the complexity, right, of our operations, but it depends on the amount of the operations that we have to do. In fact, the amount of operations actually increases almost exponentially when the degrees of freedom in the network increase. Do we all know what the degrees of freedom are? Does someone know what degrees of freedoms are? Parameters, exactly. Thanks. Because we need to start thinking about like neural networks and like all machine learning as like mathematical functions, right? In a function like f of x, we have x, which is our degree of freedom, right? In these functions, we have thousands because we have our parameters are the degrees of freedom for us. So we need a lot a lot of high performance in this case. We need to be fast, very fast, at doing very low level operations, right? So the fastest way is to use GPUs. The difference, okay, usually for those that are not computer scientists, like the CPU is the main core of the computer, right? We usually compute everything on the CPU, correct? The CPU is very, very fast, and if we have a very good CPU, we can have like 8 cores. Maybe we can go a little bit up, but we have to put down like thousands of dollars more. The GPU is not as fast, but like GPUs, even Burton talked about this. GPUs were used for graphics, and like graphical stuff has to do a lot of low-level operations, but like a ton of them. So they were already built to do this kind of thing, right? So in comparison, like for example, now NVIDIA released the GeForce Titan Volta, and the GeForce Titan Volta is like more than 5,000 CUDA cores, okay? That means that it can compute that many operations like at the same time, right? So we want to use our GPU, and since deep learning is actually a very hot field in this period, a lot of different libraries have been built to be able to use GPUs. These libraries can also work without the GPU, they can work on CPUs, but obviously they would be something like 10 times faster if we do it on GPUs. And I say 10 times because there are other things that need to be taken in account that are not only the operations, but like if we actually optimize our code, they can be like even 20, 30 times faster than our CPUs. Okay, so here you have a few instances of libraries that have been built for machine learning. The most used are actually Caffe, that was built at Berkeley. Caffe is good, but it's very stiff. It's very good at what it does, but if you have to change something in a layer or change the loss or something like that, Caffe is a nightmare. Like you have to go and change the source code, which usually you highly want to avoid. So they built Caffe 2, and Caffe 2 is a little better than that. It's still not as versatile as other libraries. I have no idea what chain it is. Not at all. There's PyTorch, which is very good. I don't know why they put MATLAB in this. MATLAB is a nightmare. Don't use MATLAB if you have to, like, MATLAB is good if you have to do like image transformations, like matrix transformations, but for deep learning, MATLAB is very, very, very slow. So possibly never use that. PyTorch is very good. PyTorch actually has the possibility of modifying the graph while going. I'll explain what the graph is later. But and this makes it very versatile, but it's not as fast as TensorFlow and is not as used in industry as TensorFlow is. So that's why actually I have been using TensorFlow for like a year and a half up to now. I used Caffe a little bit before, and Caffe is a little faster than TensorFlow when you have very common things to do, like if you use very common kind of layers, if you use very common kind of losses. But yes, I had to abandon Caffe because then I had to modify certain things, and TensorFlow lets me do it directly in Python rather than going in the code the source code and modify it. So TensorFlow is a very good thing if you want to learn. I have to discuss still with Burton. I don't know if he wants to use TensorFlow and Keras, but in my opinion, if you learn TensorFlow is like your best choice. Especially if you want to go to work in industry, TensorFlow is absolutely amazing. So, all of them though rely on CUDA. Does any of you know what CUDA is? What's CUDA?
The language in program which is used.
Exactly. CUDA is, sorry, what's your name?
Jen?
Janine? So as Janine was saying, CUDA is a language that was written by NVIDIA to use NVIDIA GPUs for like computational purposes, not only for graphical purposes, okay? So CUDA is the fastest thing you can have if you have to compute this kind of operations, right? All of these work with CUDA, someone better, someone worse, but all of these libraries have to work with CUDA. So, TensorFlow, if you go on TensorFlow's, by the way, TensorFlow is developed by Google. So if you go on TensorFlow's website, this is the first thing that they tell you. There is an open source software library for high performance numerical computation. So yes, it has a lot of built-in tools for deep learning itself. Okay. Just quickly, TensorFlow works with tensors. So tensors are multidimensional arrays. So we will store the values of our data, of all our computation in these tensors, for which we can specify the shape and have them run through our networks and receive the results and compute the derivatives to readjust the weights. Okay. You can find tutorials for TensorFlow on this website, and there are also tutorials for Tensor Board. Tensor Board is a tool that relies on TensorFlow, but that let us basically visualize everything that goes on in our neural network, right? With Tensor Board, we can actually visualize all our network, so even to see if we programmed it well. Tensor Board takes care of visualizing the weights, for example. It takes care of visualizing the loss. I usually don't use TensorFlow, Tensor Board, but it's very good. Up to now, I've been building my tools for visualization on my own, but if you want to give it a shot, this is really good, and a lot of people are using it. So there isn't a lot more to say about TensorFlow, except that we have to just dive in, right? So let's dive in. Okay. Can you read that stuff?
Could you make it a little bigger?
Yes, there is. Better? Okay. So I wrote this small tutorial so that we can actually go through it in class, and you can ask me questions. You should ask me questions, and we can see how TensorFlow works, right? At the end of the class, I will between today and tomorrow, I will post this thing on Canvas, so you can go take a look at the code, try to understand what goes on, right? So that you will be able to use it when it will be the homework. Okay. So as usual, the first thing that we have to do is import the libraries that we need in our module, right? which is very easy in Python. We just have to use the import command, and we call, okay, we need NumPy. We always need NumPy, okay? Because when TensorFlow has run everything that it has to run, the first thing that it does is returning a NumPy array with what we want, okay? So we need NumPy. We import NumPy as NP, and then we import TensorFlow as TF. And then just to show that everything went well, we print the version of both, okay? Usually if there is a problem, it gives you the error right away. The most common problem when you import TensorFlow is that you didn't link the CUDA libraries, okay? And depending on what version of TensorFlow you have, you need different CUDA libraries, okay? This shouldn't be a problem in the case of the homework, because if you're doing the homework on Collaboratory has everything already installed, okay? So if we run this piece, it should just print the version of NumPy and the version of TensorFlow. Let's go mirror now. It will probably, the connection here is not the best. Okay, at least we were able to import the stuff and print the version, okay? One thing that you always have to remember is that TensorFlow works with a session, okay? TensorFlow has basically its own runtime, right? So, and everything works in a session. When you initialize your weights, when you define the network, when you run the network, when you do anything in TensorFlow, you have to go through an instance of the class session, okay? So the first thing that you always have to do is instantiate this ses equal tf session, okay? Okay. So now we can start a small experiment. The small experiment that we start here is simply having a matrix of weight and a small matrix of examples, right? So we have W and B, that is our weights in NumPy, and our X and B, which is our examples in NumPy, right? So I instantiate them as a list, okay? And then I transform that in NumPy arrays. So just to check that everything went as we hope, we have this this printout, which is exactly what we want, right? W is a 2x3 matrix, while X and B is a 2x2. So in TensorFlow, you have to define your graph at the very beginning before using anything, okay? So when I say defining a graph, it just means that you define the network itself. The network is not running, okay? Simply we are instantiating all the weights and all the relationships between the different operations, okay? So in this case, I am converting my weights in a TensorFlow tensor, and the same thing I'm doing for my examples. And then I am defining this as the operation, right? Are you understanding what I'm saying? Do you understand this thing about the graph? Guys, this is very important because, yes.
So tf.mapMode does not store the result, it stores the operation itself. Right?
Exactly.
And we use operations to build the network later.
Yes.
Okay.
So op is just a node that's going to be in our graph.
Sorry?
So op is just going, it's basically defining a node in our graph that we're going to run.
Yes. Yes. I mean, in this case, you're defining an operation because I can define, for example, here I could define just an operation that says like x plus w. Obviously, it will break because these two things have different shapes, right? But like this is just an operation. A node in the graph is something like, I mean, technically these would be nodes too, right? So we're just building the whole graph like, well, fortunately here, no one. So we have W here, which is a node. We have X here, which is another node, right? And we have this op, which is our operation, correct? So this in this case is our graph, correct? And as what's your name? Nathan, right. So as Nathan was saying, we are only instantiating the graph right now. We are building the graph, but we are not running it yet. Even if, like, here I say print operation, right? If this was in NumPy, here it would print the result of this, because this would have already been run, correct? In the case of TensorFlow, we have also only built the graph here. We haven't run anything, because everything that we do in TensorFlow has to pass through the class session. So, if I run this piece of code, see, it doesn't return, this operation, right? It doesn't print the result of the multiplication, the matrix multiplication between these two. It just tells me what kind of like computer variable, what kind of element this is, right? So this is a tensor, and here is the name of the operation that I instantiated, and here it gives me the shape of the output of this operation and the type, right? So, I mean, there is the question there, why isn't it the output that we were expecting? Because we haven't run anything. Yes?
Maybe it's obvious, but why is there not like a way to directly make tensors? Why are we converting an NumPy array to a tensor?
Because you cannot access the values in a tensor directly. That is that is one of the problems. Every time I have to check if my network is going well, like I actually have to design an operation that then I run, and then I check the output of the operation that I run. But by itself, like this is what you would obtain because you cannot access things directly. Like tensors in TensorFlow can communicate with each other, right? Because they're nodes in a graph, but you cannot see what happens because everything is done in session. Okay?
I had a question. So I noticed matrix multiply, like the shapes, you don't have to do a transpose to do that. Like you don't have to tell it, it'll automatically, I guess, do that.
I mean, okay.
If I did that in NumPy, I'd have to transpose one of the matrices, right, to make that work.
No.
Don't you?
No,
No?
okay.
Am I
No.
looking at that wrong?
No. Just this is my x, is a 2 by 2, right? And
Oh,
this is,
sorry. I thought it was 2 by, I thought they were both 2 by 3. Sorry.
no, it's fine.
Okay.
I mean, I actually did this multiplication as Burton does it. But usually I do it like the opposite. I store usually the samples in columns rather than in rows, right? So since I do that, I actually have to swap these two, correct?
Okay. So you do have to make sure that it all.
Yes, you still have to make sure that it does it Well, otherwise it will throw the same error that NumPy will throw.
Okay.
Okay? Any other question? Okay. If I am talking and you raise your hand and I don't see you, just me. Okay? Thanks. So, okay. Have we understood this part? This is very important. Like, I'm giving you this tutorial because I know that from like next homework you will have all these problems. All of them. So, okay? So, okay, we can go on. I already explained this part. Have you understood everything up to now? Okay. So now we can actually run the operation that we designed, and we can store it in a variable, right? I'm calling this variable oprun. So if I run it, see that this is a matrix that is a 2 by 3, which is what I was expecting, right? So,
what's the type of the operand?
Oops.
What is the type of the operand? Is it just a on list or?
Oh, like the output you mean? This is an NumPy array.
Okay.
This is an NumPy array. Let me check. If
Is it underscore?
right. Thanks, guys. Okay. So yes, it's a NumPy array. Okay. Which is actually very nice because if you learn how to use NumPy, actually you learn very well how to build the graphs for TensorFlow, because like many of the functions that you have for TensorFlow are actually probably written like in the same fashion than NumPy. So yeah. Now, if you, well, I mean, I wrote this piece of code that simply computes the same operation, but like element-wise, right, one by one. So, and as you can see, the numbers are the same except for the small error in the last bit. But yeah, so the system works. TensorFlow does what we're expecting it to do, correct? So, to summarize, we need to define the variables that will be used for our operation. Then we need to define the whole graph in TensorFlow that will lead to the operation's output. And then we need to run the operation that we want to run in the TF session.run, right? The only thing we need to do when we have defined our graph is only to run the bottom operation that we need to run, because then TensorFlow from inside will basically go back and will climb backwards all the nodes to be able to compute this. Okay, so we don't have to first run this and then run this and then run this. Only this, and it will just do it on its own. Okay. Okay. So now we're going to something a little bit different. Okay. So up to now, I've told you how to build a very simple operation, right? And the graph was built like this. Now I will show you how to build an actual neural network in TensorFlow. Okay, there are a few more things that we need to take care of. First of all, what is the difference between this graph, like the variable in this graph, and the variables in a neural network? What should I do with, like, what is the difference between what I did before with those variables and the thing that I should do with the variables in a neural network? Any idea? No? did I change these variables? Like, did I change the variable w or the variable x in the previous operation? Not really, right? But our neural network needs to be able to learn, correct? So we need to be able to change the variables. Perfect. Applying our derivatives as we learned in the past lectures and all this, right? So the main thing is that TensorFlow needs to know that like something is that a tensor is a variable. That means that will be modified while the program is running. Correct? Okay. This is the first thing. Let's start actually just defining a small problem, okay? So for this neural network, I define the problem like this. I have a series of points, okay, in a 2D space. And I want to divide them into all those that fall into the unit circle and those that don't fall into the unit circle. Is this clear? Right? Just I have points all around, right? So this is my unit circle. And so all those that will follow into this circle will have one label, and all the others will have another one. So these will be ones, and these will be zeros. Okay? It's a very simple problem, so that I can show you how to build stuff in TensorFlow. Okay? Because I could have used like MNIST, but it's a little bit more. It's a little bit, like a pain, I would say. So, so the first thing I'm doing here is creating these points, and I all create them like from a normal distribution with mean 0 standard deviation 1, right? So it would be very easy even to just visualize it. And so I create I have train X, which corresponds to my data, and train Y, which corresponds to my labels, right? So all those that fall inside those will become ones, and all the others will become zeros. Okay? Yes, sir. Okay. In TensorFlow, then you want to define the network. The best thing you can do to define the network is usually defining the network inside its own function, right? So the function here takes our input data, and what am I doing here? Okay. Yes. It takes our input data, it creates the variables, like the first matrix of weights, the first vector of biases, it computes the matrix multiplication, it adds the bias, and then it applies the rule. Okay? Then it creates W2, my second matrix of weights, my second vector of biases, and it computes the multiplication between W2 and the output of the first layer, and then adds the bias, and just returns this. It's a two-layer, fully connected network. Yes?
I may have just missed this. Where did the variables come from? W1, V1, W2, V2. Did you define those variables?
No, we didn't. Okay. We define.
So are we just assuming that, because these are not like actual terminology. These are operations only. They're not actually doing operations, right? Like you just said.
I'm just building a graph.
So
Actually, I am defining a function. Since I haven't called the function, I haven't built anything.
Right. So we're just assuming that W1 and B1 will be present in the session when we run the session.
Yes.
Okay.
Because before running the session, we build the graph. So before running the session, we will call this function. Okay? So, okay, the difference that you may see here between this and what we did before is that before I defined the weights in NumPy before transforming them in tensors, right? While in this case, I am actually calling tf.getVariable. This function creates a variable when we call it, just in TensorFlow. And it takes a name for the variable, which we call w1, and an initializer. The initializer can be either a function in TensorFlow, like in this case, or if I wanted, I could have created like an NumPy array with my weights, and then I could have used those weights as initializer. Does it make sense? Guys, I need at least a yes, please.
Yes.
Thank you. You.
So with the get variable, if we already have that w1 variable in our graph, is it going to use that instead? And then if it's not in our graph, is it going to create w1 for us? Is that how it works?
Okay. How it works is if it's not in our if w1 is not in our graph, okay. First of all, there is another instantiation of a variable which would be just tf.variable. Okay. You could avoid putting in a name, but then if you have to retrieve that variable, you can't. Okay. So this is actually the most useful way I found, like, for a lot of reasons, even because like when you want to use multiple GPUs, this makes it way easier than the other one. Way easier means I have never been able to use it with the other one. So, if W1 doesn't exist, it creates it. If W1 exists, it gives you an error. So, unless you do something else, but I'll show you later. Okay?
So the w1 that you're passing to the function is the name of the variable, right?
Yes, it's a string.
And what is the w1 that's getting assigned outside? So
This is a variable. Okay, this is I am assigning w1 to be this thing. Okay, this is just the name of the string. This is just a string that will become the name of the variable in TensorFlow.
And the outside one is like the name of the operation?
The outside one stores the tensor itself, okay, and that is a little bit complicated to understand. Okay, let me see. This W1 will store the tensor that contains that variable, okay? But TensorFlow itself considers, like the session when it runs, considers the name, this name, okay? Have you ever programmed in like C++ or C? Okay, this is basically just the what do you call it, the reference?
Object of the class.
What?
Object of the class.
Sorry, the pointer. That is what it was. Okay, this is basically the pointer. Okay, when you call in Python you don't have pointers really. Okay, so when you call this, like this w1, it will retrieve the variable that is stored in session.
So can I have multiple variables in the same tensor?
What do you mean?
So can I do w1? Can I do like store two variables in the same tensor?
Two variables with w1.
Yes.
Same tensor.
Why would you do that?
Am I able to do that? That's just
I don't think so, but
So
there
it's
is
like
no reason for
it's
you
like
to
a one-to-one match between that.
I mean, you can put all these variables that you're storing here, like in a list if you want. You can put them in a tensor, like TensorFlow, and it calculates the derivatives. We'll have a tensor of tensors, and blah 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 blah. But for you, I would suggest not to do that, because otherwise you will lose track very fast of what happens. So yeah. There were other questions. You.
So maybe this is like a terminology clarification. Are we saying that like a variable is basically like a mutable tensor, and like a tensor is normally immutable?
Yes.
Okay.
Yes. Basically, when you initialize something with get variable, you're basically saying this is something that will change. Okay. Not necessarily, because you can actually freeze it. But let me think. Because, okay, a tensor is just a variable is something a little bigger than a tensor, in the sense that, like, a variable contains a tensor, okay? But, okay, if you want to change something, you can't use tensors. But you can, there's many ways you can actually freeze a variable and avoid to update it every time, right? Which is what happens like often in, like, do you know like generative adversarial networks? You have a generator and you have a discriminator, and you want to train first the discriminator and freeze the generator, and then you want to train the generator and freeze the discriminator. And you keep doing that. So there are ways for which you can actually use the whole graph with all its variables, but only update some. Okay. Sorry, does it answer your question?
Yeah.
Okay. Okay.
And is get just like a misuse of words that usually implies like you're grabbing an existing thing? And it sounds like you're making something.
You can grab, yes. You can, if going back to what you were asking actually. If you use get variable, if it exists, it creates one and retrieves it. If it doesn't exist, it creates the variable and retrieves it. If the variable already exists, it just retrieves it. While if you use tf.variable, you are not actually retrieving the variable itself. Okay? You only create a variable with tf.variables. Another thing I just wanted you to notice is that like TensorFlow has a lot of these kind of functions, okay, and has a lot of functions that define like convolutional layers or like up convolutions, and like this is pretty much everything I'm using. But like there's plenty of these things, and even like the activations, there's plenty of activations that TensorFlow is doing. The cool thing about TensorFlow is that actually you can create very easily your own layer functions basically, and your own losses and your own activations. So for example, like TensorFlow doesn't have a built-in leaky relu, but you can very easily create it on your own and use it. And TensorFlow, see, can you read this, please? Not you. Can you read this?
This super ultra mega cool thing
Yes.
that TensorFlow is able to calculate the derivatives for a lot of losses, even if manually defined. That is
Exactly.
very akin to black magic.
Yes. Actually it is. I have no idea how it does it, so that means that sooner or later it will really screw me over. Because, but up to now there's never been a problem for me. But like even for the ones that we create, it's like the graph is able to calculate the right functions for the derivative.